Hello there, and welcome to the Sleepless Scientist, a quiet place where your thoughts can loosen their grip, and curiosity is allowed to drift at its own gentle pace. Tonight, we're going to explore something so familiar that it usually escapes our attention, something that shapes every moment of your life without ever asking permission. Tonight's journey is about time. Before we begin, you might want to make yourself comfortable. Dim the lights, let the room settle into stillness. Perhaps there's a soft hum in the background, a fan, distant traffic, or the quiet rhythm of your own breathing. If you enjoy these calm explorations of science and wonder, you're always welcome to like this video or subscribe, but only if it feels right. And when you're ready, you can leave a comment telling me where in the world you're listening from, and what time it is for you right now. It's always fascinating to imagine all these moments unfolding at once, each listener resting in their own small slice of the universe. Now, there's nothing you need to remember, nothing you need to solve. If your mind wanders, that's perfectly fine. Let it wander. We'll still be here, gently unfolding the story. Let's begin by noticing how time feels. Time, for most of us, begins as a set of numbers. Numbers on a phone screen, numbers glowing on a microwave, numbers we glance at before deciding whether we can sleep a little longer or whether the day has already claimed us. We plan our lives around these numbers. We wake by them. We rush because of them. We measure success, lateness, and deadlines with their steady march forward. Yet, strangely, time doesn't always feel like numbers. Think back to childhood summers, days that seemed to stretch endlessly, mornings that blended into afternoons without concern. There were no appointments to keep, no alarms demanding attention. The day began when the sun climbed high enough, and it ended when the light finally softened into evening. Back then, time didn't feel like something you were running out of. It felt more like a wide open field. Somewhere along the way, that changed. As adults, many of us feel as though we're constantly racing against time. We speak of saving time, wasting time, running out of time, as if it were a physical substance slipping through our fingers. We talk about time the way we talk about money or fuel, something finite, something to be managed carefully. But what exactly are we racing against? Is time an actual thing, built into the universe like matter and energy? Or is it something more subtle? A system we invented to organize our lives, a mental framework layered on top of reality to help civilizations function? It sounds like a simple question. But when you pause and try to answer it, it becomes surprisingly slippery. What is time? Many people describe time as what keeps everything from happening all at once. Others say it's what orders events, arranging them into a sequence so that one thing can follow another. These explanations feel intuitively right, yet they don't quite tell us what time actually is. They tell us what time does, not what it is. What's more curious is that time seems to behave differently depending on how we encounter it. A minute waiting for a message can feel longer than an hour spent in conversation. A moment of fear can stretch itself thin, while a peaceful afternoon can vanish without warning. The clock continues ticking at the same pace, but our experience does not. This mismatch hints at something important. It suggests that there may be more than one kind of time at work. One time that clocks measure, and another time that the mind experiences. Clocks, after all, are inventions. They are tools we built to count repeating motions, the swing of a pendulum, the vibration of atoms, the steady oscillation of electrical signals. Clocks do not detect time directly. They detect change, and they convert that change into numbers we can share and agree upon. When we say it's 9 o'clock, what we really mean is that a particular pattern of motion has repeated itself a certain number of times since we last reset the count. Time, in this sense, is not something the clock reveals. It is something the clock helps us coordinate, and yet Even before clocks existed, people lived within time. Seasons passed, bodies aged, stars rose and set. Something was unfolding, whether it was measured or not. So perhaps time is not the numbers. Perhaps the numbers are just our way of pointing at something deeper. As we begin this journey, it helps to hold two ideas gently in mind. The first is that time, as you experience it, is deeply personal. No one else feels the exact same minute the way you do. The second is that the universe itself may not experience time in the way we do at all. Over the course of this exploration, we'll move slowly from the time of everyday life into the time of physics, then into the time of the brain, and eventually into the time of the cosmos itself. Along the way, familiar ideas will soften. Solid assumptions may blur at the edges. That's not a problem. That's part of the process. For now, there's no need to go anywhere beyond this moment. Just notice that you are here, listening, breathing, existing in what feels like now. That sense of now may seem obvious, even undeniable. But as we'll soon discover, it may be one of the most carefully constructed illusions the universe has ever allowed us to experience. And as we let that thought settle, we can begin to gently shift our attention toward a deeper question, not about how time feels, but about what time might truly be. We left off by noticing how time feels. Elastic, personal, sometimes rushing, sometimes lingering. Without any sharp break, that feeling naturally invites a quieter question, one that has followed humans for as long as we've paid attention to the passing of days. If time can feel so different from one moment to the next, then what exactly is it that we're dealing with? Is time something out there in the universe, ticking away whether we notice it or not, or is it something closer to a tool we use to organize experience? At first glance, time seems obvious. We can point to clocks, calendars, schedules. We can coordinate meetings, plan journeys, and agree on when something happened. Entire civilizations depend on this shared structure. Trains run because time is standardized. Communication works because people agree on when now is supposed to be. In this sense, time looks very real, sturdy enough to hold societies together. But there is a subtle distinction hiding here. Clocks do not actually measure time itself. What they measure is repetition. A pendulum swings back and forth. A crystal vibrates. At the deepest level, certain atoms hum with extraordinary regularity. We choose one of these repeating motions, count how often it happens, and call that count time. The clock is not sensing an invisible river flowing past us, it is counting change. This may sound like a technical point, but it carries a surprisingly gentle implication. If clocks are really just counting changes, then time might not be a substance at all. It might be a way of keeping track. Imagine, for a moment, a world without clocks. There are no watches, no calendars, no glowing digits anywhere. Would events still happen? Of course they would. The sun would still rise and set. People would still grow tired, hungry, and old. What would disappear is not change itself, but our numerical grip on it. This idea has led many scientists and philosophers to suggest that time may not be something built into the universe, like matter or energy. Instead, it may be a framework we impose to make sense of change. In other words, time might be less like a physical object and more like a map. Maps are useful. They allow us to navigate complex terrain, but a map is not the land itself. It highlights certain features and ignores others. It simplifies reality so that we can function within it. Time, in this view, may be doing something very similar. It simplifies the unfolding of events into an ordered story we can understand. This perspective becomes even more interesting when we look back at how people once thought about time. For centuries, time was imagined as something absolute. A universal background that ticked forward at the same pace everywhere, regardless of what was happening. The universe, in this picture, was like a giant clock that had been wound up at the beginning and left to run. This idea felt comforting. It meant that there was a single, shared rhythm beneath everything. No matter where you were or what you were doing, time itself marched on steadily in the background. But there was a problem. No one could ever directly observe this absolute time. We never experience time on its own. We only experience events, movements, changes. Time, as an independent thing, has remained strangely invisible. Gradually, this led to a quieter realization. Perhaps time does not exist independently of events at all. Perhaps time is nothing more than the web of relationships between changes. When one thing happens before another, we call that sequence time. When many changes line up in patterns, we call that a timeline. A simple metaphor helps here. Think of music played by a small group of musicians. There does not need to be a metronome ticking in the background for rhythm to exist. As soon as the musicians begin playing together, a sense of timing emerges naturally from the relationships between the notes. The rhythm lives in the interaction, not in an external ticking device. In this sense, time could be like rhythm. Not something imposed from outside, but something that arises when events relate to one another. This view gently shifts the question. Instead of asking, what is time made of, we begin to ask, what must exist for time to appear? The answer may be surprisingly simple: change. Without change, there is nothing to order, nothing to sequence, nothing to count. Without change, time loses its meaning, yet our experience of time still feels powerful and deeply real. This is because time, even if it is a tool, is one we use constantly. It shapes memory, expectation, and identity. We remember the past. We anticipate the future. We experience ourselves as moving through a story. That story gives life coherence. So time may not be a thing you can point to in the universe, but it is also not an illusion you can simply dismiss. It may be something in between, a cognitive technology, a way intelligent beings organize change so that life becomes navigable. As this idea settles, it prepares us for an even more surprising turn. Because when physicists began to look closely at how the universe itself behaves, they found that time is not only relational, but deeply intertwined with space in ways that challenge our most basic intuitions. The familiar sense of a single, steady timeline begins to soften, and something much stranger quietly takes its place. But we don't need to rush there. For now, it's enough to sit with the possibility that time might be less like a flowing river and more like a carefully drawn chart. Immensely useful, deeply influential, and yet not quite the same thing as reality itself. As the idea of time as a tool rather than a substance settles quietly in the background, it becomes easier to understand why earlier generations thought about time very differently. For a long stretch of human history, time felt solid, dependable, and absolute. It was imagined as something that existed independently of everything else, flowing steadily whether anything happened or not. This way of thinking did not arise from carelessness. It arose because, on everyday scales, it works remarkably well. Picture the universe as it was once imagined, a vast, orderly machine. Planets moved in predictable paths. Seasons returned on schedule. The stars traced familiar patterns across the sky. Beneath all of this motion, time was thought to tick forward at a constant pace, like a metronome set at the beginning of creation. Even if the universe were empty, even if nothing at all were happening, time itself would still be there, quietly advancing. This idea gave people comfort. It suggested stability. It implied that there was a single cosmic rhythm shared by everything, everywhere. Whether you were standing still or racing across the earth, whether you were watching the sky or sleeping through the night, time was assumed to treat everyone equally. For a long time, no one had much reason to doubt this picture. After all, everyday experience seems to confirm it. An hour feels like an hour. A day feels like a day. If two people compare watches, they usually agree. The world appears synchronized. But hidden beneath this apparent simplicity was a quiet problem. Absolute time, as comforting as it sounded, could never actually be detected on its own. No one could point to time directly. No experiment could isolate it. What people measured instead were always motions and changes. Shadows moved, pendulums swung, water dripped. The ticking of clocks was always tied to something physical happening in space. This raises an uncomfortable question. If time is truly independent of everything else, why can we never observe it without observing change? Imagine trying to detect time in a universe where nothing moves, no particles collide, no light travels, no processes unfold. In such a universe, how would anyone know that time was passing at all? Without change, time would leave no trace. This realization began to erode the idea of a clockwork universe. Slowly, the notion that time was a universal background started to look less like a fact and more like an assumption. Another crack appeared when people began comparing clocks more carefully. As clocks became more precise, subtle discrepancies emerged. Not errors caused by poor craftsmanship, but differences that depended on motion and position. These differences were tiny at first, far too small to notice in daily life, but they hinted at something deeply unsettling. Time might not be as uniform as it seemed. The old picture imagined the universe as a perfectly synchronized orchestra, with every instrument following the same beat. But what if there was no universal conductor? What if each instrument kept its own time, shaped by where it was and how it moved? This is where the metaphor of the clock begins to fail. A clock suggests an external standard, something separate from the events it measures. But if time cannot be separated from events, then the clock is not revealing time's true nature. It is simply offering a convenient approximation. To understand why this matters, it helps to return to the idea of change. Suppose you remove all clocks from a room and ask people to coordinate their actions. They might begin by watching one another. Someone moves, another responds. Patterns form, sequences emerge. Very quickly, a shared sense of timing develops, even without numbers or ticking devices. The timing arises from relationships, not from an external reference. This is a profound shift. It suggests that time may not be something that exists first, with events happening inside it. Instead, events may come first, and time emerges from the way those events relate to one another. In the clockwork universe, time was like a stage on which reality performed. In the newer view that began to take shape, as time looks more like a story woven from interactions. Without interactions, there is no story. Without a story, the idea of time loses its meaning. Yet the appeal of absolute time lingers, because it aligns so neatly with how we experience life. We wake up, go about our day, and go to sleep. It feels as though time flows past us, indifferent to our actions. That feeling is real, even if the underlying picture is not. What we are beginning to see is that human intuition is an unreliable guide at cosmic scales. The universe does not have to behave in ways that feel natural to us. The sense of a steady, universal time may be less a property of reality and more a reflection of how our minds prefer to organize experience. This realization sets the stage for one of the most important transitions in modern science. When physicists finally let go of the idea of absolute time, they uncovered a universe far stranger and more elegant than the clockwork model ever allowed. Time did not disappear, but it changed character. It became flexible, relational, and inseparable from space itself. For now, it is enough to recognise that the clockwork universe was not foolish. It was a stepping stone. It provided a framework sturdy enough to build early science upon. But like many useful ideas, it turned out to be an approximation, not the final word. As we rest with this thought, the steady ticking of absolute time begins to fade. In its place, a more fluid picture quietly takes form, one in which time bends, stretches, and depends on the very things it was once thought to govern. That softer, stranger picture will gently come into focus as we continue. As the idea of a clockwork universe gently loosens its grip, another way of thinking begins to emerge, quieter at first, but ultimately far more flexible. Instead of imagining time as something that exists on its own, ticking steadily in the background, we begin to imagine time as something that arises from relationships. Not a thing, but a pattern. Not a container, but a consequence. To understand this shift, it helps to return to something very simple. Imagine sitting in a room with no clocks, no phones, no windows, nothing that tells you what time it is. At first, the absence might feel unsettling, but soon, other cues take over. You notice your breathing. You notice hunger arriving gradually. You notice the subtle fatigue behind your eyes. Change continues even without numbers attached to it. Now imagine that someone else is in the room with you. They speak. You respond. A rhythm forms between your words. One voice pauses, the other fills the space. Even without a clock, there is timing. There is a before and an after. There is a sense of sequence. This is the heart of relational time. In this view, time does not exist independently of events. Instead, it emerges from the way events relate to one another. One change followed by another creates an order. That order, taken together, is what we call time. A useful image is music. When musicians play together, rhythm appears. There does not need to be a ticking device enforcing the beat. The timing emerges naturally from the relationships between sounds. A note held slightly longer invites a pause. A faster passage pulls the rhythm forward. Time in music is not imposed, right? It is created. If the musician stops playing, the rhythm vanishes. Not because time itself has disappeared, but because the relationships that created it are no longer there. This perspective solves a puzzle that absolute time never could. It explains why we cannot detect time on its own. If time is not a substance but a pattern formed by change, then looking for time without change is like looking for rhythm without sound. There is nothing to find. From this point of view, clocks take on a new role. They are no longer measuring an invisible river of time. They are simply counting regular changes and using those changes as a reference. A clock does not reveal what time is. It helps different observers agree on when things happen relative to one another. This idea may feel subtle, but it has profound consequences. It suggests that time is not something the universe carries with it everywhere, like a universal heartbeat. Instead, time is something the universe produces locally, wherever there is change and interaction. This also means that time can behave differently in different situations. If relationships between events change, then the time that emerges from those relationships can change as well. This is not yet the strange time of bending and stretching, but it is the first step toward it. Another way to picture this is to imagine a dance. There is no time floating above the dancers, telling them when to move. Time appears in the dance itself, in the spacing of steps and the flow of motion. Slow movements create one kind of time. Quick movements create another. The dance defines the tempo. When scientists began to take relational time seriously, they found that it fits surprisingly well with how the universe actually behaves. Motion, energy, and interaction became central. Time stopped being a background and started becoming a participant. This shift also softened a long-standing tension between physics and experience. We feel time because we experience change. Our memories record sequences. Our expectations anticipate what comes next. Time, as lived, is inseparable from these processes. Relational time acknowledges that connection instead of denying it. Yet this view also challenges something deeply ingrained. If time depends on relationships, then there may be no single, universal time that everyone shares. Different systems, experiencing different kinds of change, could generate different kinds of time. At first, this sounds unsettling. We're used to the idea that now is shared, that there is a single present moment stretching across the universe. But relational time gently suggests otherwise. It hints that now might be something local, something that arises from nearby interactions, rather than something stamped onto the cosmos as a whole. This idea does not yet demand that time bends or slows. It only asks us to release the assumption that time exists independently of everything else. Once that assumption is gone, the door quietly opens to a much stranger landscape. The universe, it turns out, does not need a master clock. It does not need a ticking background to keep events in order. Order emerges naturally from change itself. Time, rather than commanding the universe, may be something the universe creates as it goes along. As this realization settles, it prepares us for a deeper transformation. If time is relational, then it may also be flexible. And if it is flexible, then it may be inseparable from the very fabric of space. That realization, still ahead of us, will take relational time and weave it into something even more unexpected. For now, it is enough to let the image of time as a pattern linger. Not a river flowing past us, but a rhythm formed by movement. Not an invisible force, but a story written by change itself. As the idea of relational time settles into place, another realization begins to surface, one that quietly reshapes everything that came before. If time is not a rigid background, if it emerges from relationships and change, then it may not stand apart from the rest of reality at all. Instead, time may be woven directly into the same fabric as space itself. To appreciate how radical this idea is, it helps to notice how naturally we separate space and time in everyday life. Space feels solid and navigable. You can move left or right, forward or backward. You can point to locations and measure distances. Time, on the other hand, feels intangible. You can remember yesterday and imagine tomorrow, but you cannot step into them. Space feels like a place. Time feels like a flow. For a long time, physics agreed with this intuition. Space and time were treated as separate things, each with its own rules. Space described where events happened. Time described when they happened. Together, they formed a convenient coordinate system for mapping the universe. Then that separation began to dissolve. The key insight was surprisingly simple. If time is defined by change, and change depends on motion, then time cannot be entirely independent of space. Motion happens through space. Events unfold at specific locations. If space influences how events relate to one another, then it must also influence the time that emerges from those relationships. This led to a profound reimagining. Instead of space and time existing side by side, they were unified into a single structure, a four-dimensional fabric often described as space-time. In this picture, space provides three directions you can move through, while time provides a fourth direction that orders events. They are not separate ingredients mixed together. They are aspects of the same underlying reality. A gentle metaphor helps here. Imagine a woven cloth. You cannot pull on one thread without affecting the others. Stretch the fabric in one direction, and it tightens somewhere else. Space and time behave in a similar way. Change one, and the other responds. This becomes especially clear when gravity enters the picture. Gravity is often described as a force pulling objects together. But in this deeper view, gravity is better understood as a bending of space-time itself. Massive objects like planets and stars gently curve the fabric around them. Objects moving through that curved fabric follow paths that look, to us, like gravitational attraction. What is easy to miss is that time bends along with space. Near a massive object, time passes more slowly, not in a metaphorical sense, but in a measurable physical way. A clock placed closer to a large mass ticks slightly more slowly than an identical clock placed farther away. The difference is tiny under everyday conditions, but it is real. To translate this softly, imagine time as a flowing stream. Near a heavy object, the stream runs a little deeper and a little slower. Farther away, it flows more freely. Nothing dramatic happens. No one notices in daily life. But the difference is there, quietly accumulating. Motion has a similar effect. When something moves very quickly through space, time for that object slows down relative to things that remain still. Again, this is not about perception. It is about how much change actually unfolds. A fast-moving system experiences fewer internal changes than a slower one. Together, gravity and motion reveal something extraordinary. There is no single universal pace at which time flows. Each object carries its own version of time, shaped by where it is and how it moves. This may sound abstract, but it has practical consequences. Modern navigation systems must account for these effects to function correctly. Clocks in satellites orbiting Earth tick at a slightly different rate than clocks on the ground. If engineers ignored this difference, navigation errors would grow rapidly. The technology works precisely because time is flexible. This flexibility challenges the idea of a universal now. If time flows at different rates in different places, then the present moment cannot be the same everywhere. What feels like now for one observer may not align perfectly with now for another. This does not mean that time becomes chaotic. It means that time becomes local. It belongs to specific paths through space-time rather than to the universe as a whole. At first, this realization can feel unsettling. We're accustomed to the idea that reality unfolds in a shared present, but space-time gently suggests a different picture. Reality may be laid out as a vast structure in which each observer traces their own path, carrying their own sense of time along with them. In this view, time does not disappear. It becomes personal, contextual, and inseparable from motion and gravity. It is no longer a background stage. It is part of the set. As we rest with this idea, it becomes clear that the universe is not organized around a single ticking clock. Instead, it is organized around relationships, between events, between locations, and between paths through space-time. Time emerges along those paths, shaped by the geometry of the universe itself. This realization prepares us for an even more intriguing thought. If space and time are woven together, and if time flows differently depending on how you move through that fabric, then the familiar sense of past, present, and future may not be as absolute as it feels. The idea of a shared now begins to soften at the edges. We do not need to resolve that thought just yet. For now, it is enough to recognize that time has stepped fully into the structure of the universe. It bends, it stretches, it responds, and in doing so, it quietly invites us to reconsider what it really means to exist in a moment at all. As the idea of space-time quietly settles, a natural question drifts into view. If time truly bends and stretches, if it flows differently depending on motion and gravity, how could we ever know? These effects sound subtle, almost philosophical. It would mean nothing if they remained forever beyond our ability to test. And yet, one of the most reassuring aspects of science is that even the strangest ideas eventually face a simple demand. Show me. The answer arrived not through telescopes or particle explosions, but through clocks. Not ordinary clocks, but clocks so precise that they can sense the faintest whispers of change in time itself. To understand why clocks matter here, it helps to recall what a clock really is. A clock is a device that counts a regular, repeating motion. The more stable and predictable that motion is, the better the clock. For centuries, people relied on swinging pendulums, dripping water, or vibrating crystals. These worked well enough for daily life, but they were not sensitive enough to detect the subtle flexibility of time predicted by space-time. Eventually, scientists discovered a far more reliable rhythm. Deep inside atoms, certain particles oscillate with astonishing consistency. These oscillations are not influenced by temperature, wear, or fatigue. They're as close to perfect as nature allows. By counting these atomic vibrations, scientists built clocks that lose less than a single second over spans of time longer than recorded human history. These clocks are so precise that they can detect changes in time caused by differences smaller than a human step. This precision allowed scientists to perform an elegant experiment. Two identical atomic clocks were synchronized perfectly, ticking in unison. One clock was then moved slightly higher than the other, only a small distance upward. According to the idea of space-time, the higher clock should experience slightly weaker gravity, and as a result, time should flow just a bit faster for it. The difference was tiny, so tiny that no human could ever feel it. But the clocks noticed. After some time passed, the two clocks no longer agreed. The higher clock had advanced ever so slightly more than the lower one. Time, it turned out, had passed differently for the two clocks simply because they occupied different positions in a gravitational field. This was not a one-time curiosity. The result was repeatable, predictable, measurable. Time truly was flexible. Another version of this experiment involved motion rather than height. A clock carried on a fast-moving vehicle was compared with one that remained still. When the travelling clock returned, it lagged behind its stationary partner. Time for the moving clock had passed more slowly. To translate this softly, imagine two identical candles burning at the same rate. One candle sits quietly on a table, the other is carried along a fast-moving path. When the journey ends, the travelling candle has burned down slightly less. Fewer changes occurred within it. Its internal processes unfolded more slowly. That difference is time dilation made visible. These results were not philosophical interpretations layered onto data. They were direct observations. Time itself behaved differently under different conditions. Perhaps the most striking confirmation of this comes from technology we now take for granted. Satellites orbiting Earth carry atomic clocks on board. These satellites move quickly and sit higher in Earth's gravitational field than clocks on the ground. Both effects influence time in opposite ways. Motion slows their clocks. Reduced gravity speeds them up. Engineers must account for both effects. If they did not, navigation systems would drift rapidly, placing locations kilometers away from where they should be. The fact that your phone can guide you accurately through a city is quiet proof that time does not flow uniformly. What makes this remarkable is not just the accuracy, but the implication. Time is not a universal metronome. It does not tick identically everywhere. Instead, time responds to the structure of space-time. It is shaped by mass, motion, and geometry. And yet, despite this flexibility, time remains reliable enough to support everyday life. The differences are small because the conditions we live under are gentle. Earth's gravity is moderate. Our speeds are slow compared to the universe's ultimate limits. Under these conditions, your time behaves almost like the absolute background we once imagined. Almost, but not quite. This explains why the old picture of time worked for so long. It was not wrong in daily life. It was incomplete at deeper levels. As this realization settles, it becomes easier to let go of the idea that there must be a single, shared, present moment stretching across the cosmos. If clocks disagree depending on where they are and how they move, then now cannot be universal. It must be something local, something tied to each observer's path through space-time. This does not make reality chaotic. It makes it richer. Each observer carries their own timeline, shaped gently by the journey they take through the universe. Time becomes a companion rather than a ruler. And here quietly we arrive at a turning point. The flexibility of time is no longer an abstract prediction. It is a measured fact. It shows up in experiments, in technology, and in the devices that guide us through daily life. With this foundation in place, a deeper question naturally emerges. If time can flow differently for different observers, and if each observer carries their own version of time, then what does it really mean to say that something is happening now? That question leads us toward a picture of the universe that is at once unsettling and strangely serene, where past, present, and future may coexist in ways we are not used to imagining. For the moment, it is enough to appreciate the quiet elegance of these clocks. They do not shout. They do not dramatize. They simply tick, faithfully revealing that time is not what it once seemed, and that reality is far more flexible than our instincts ever suggested. As the quiet ticking of perfect clocks fades into the background, their message lingers. Time does not move at the same pace everywhere. It bends, stretches, and responds to motion and gravity. Once that idea is allowed to settle, another, even more unusual picture begins to come into focus. It is not loud or dramatic. It arrives gently, almost reluctantly. But once seen, it is difficult to unsee. If time flows differently for different observers, then the notion of a single shared present becomes hard to defend. The idea that the entire universe agrees on what is happening right now starts to soften. And from that softness, a new way of imagining reality quietly emerges. This picture is often described as the block universe. To approach it calmly, imagine space first. All of space exists at once. Mountains, oceans, cities, and empty stretches between stars all coexist, even though you can only stand in one place at a time. You do not think that distant locations pop into existence only when you look at them. You accept that they are there, even if you are not. The block universe asks a simple but unsettling question. If all of space exists together, why not all of time as well? In this view, the past has not vanished, and the future is not waiting to be created. Instead, past, present, and future all exist as part of a single structure. They are not stacked in a flowing sequence, but laid out like different regions of a vast landscape. What we call now is simply the place where our awareness happens to be. Now, this does not mean that everything is happening at once in a chaotic blur. Just as different places in space are separate, different moments in time are separate. They are real, but they are not all here. A helpful image is a loaf of bread. Each slice represents a moment. All the slices exist together as part of the loaf, but you experience them one at a time as you cut through. Nothing is created by the slicing. The loaf already exists. The slicing only reveals different cross-sections. In the block universe, your life is like a path carved through this loaf. Birth is one slice. Childhood is another. The moment you're listening now is yet another. They are all there, fixed in the structure, even though you encounter them sequentially. This idea often raises an immediate concern. If the future already exists, what does that mean it is predetermined? Are choices illusions? Does anything truly change? The calm answer is that change still exists within the structure. Events differ from one slice to the next. Decisions have consequences. Causes lead to effects. What disappears is not change, but the idea that the future is being created moment by moment. Instead, the entire story exists, even though you only read it one page at a time. What makes the block universe especially compelling is that it fits naturally with the flexibility of time revealed by space-time. If different observers slice space-time differently, then there cannot be a single, universal way to divide reality into past, present, and future. Each observer carries their own now angled slightly differently depending on their motion and position. Light plays a subtle role here, Jesus. Because light takes time to travel, your present moment already includes events from different pasts. The light from a nearby object arrives almost instantly. The light from a distant star arrives years later. Your now quietly gathers together moments that occurred at different times elsewhere. This blending is not an error. It is a natural consequence of how information moves through space-time. Someone far away would gather a different blend. Their present would include different events from your past and future. Neither perspective is privileged. Each is simply a different way of slicing the same structure. This can feel deeply counterintuitive because our experience insists on a flowing present. It feels as though time is moving, carrying us from one moment to the next. But the block universe suggests a gentler explanation. Perhaps it is not time that moves. Perhaps it is consciousness. Our awareness traces a path through space-time, lighting up one slice after another. Memory gives us access to earlier slices. Expectation gestures toward later ones. But the movement belongs to experience, not to time itself. In this view, the sense of passage becomes something the brain constructs, much like depth or colour. It is a useful feature of perception, helping us navigate a complex world. But it may not reflect the underlying structure of reality. The idea does not diminish life. If anything, it gives it a quiet solidity. Moments do not vanish into nothingness. They remain, woven into the fabric of space-time. The laughter you remember, the rest you once felt, the small kindness you offered. These are not erased. They are part of the structure. At the same time, the future is not something you can reach ahead of schedule. Just as you cannot step into a distant place without travelling through space, you cannot step into a distant time without travelling along your path. The structure may be complete, but your experience of it remains local and limited. As this picture settles, the universe begins to feel less like a river and more like a landscape. Not static in a lifeless way, but complete in a peaceful one. Events are arranged. Relationships are fixed. Meaning arises from connections across slices. This prepares us for the next quiet realization. If all moments exist together, and if now depends on perspective, then our shared sense of the present may be more fragile than we think. The feeling that everyone agrees on what is happening may be a convenient illusion, held together by the short distances and slow speeds of everyday life. We do not need to challenge that illusion yet. For now, it is enough to let the image rest. A universe where time does not flow, but where experience does. A reality where moments are not lost, but placed. A structure vast enough to hold every before and after, even as we move through it gently, one awareness at a time. As the idea of the block universe gently settles, another assumption quietly loosens its hold. It is an assumption so familiar that we rarely notice it, one that feels almost self-evident. The assumption that there is a single, shared present moment, a universal now that stretches across the entire universe, binding all events together in the same instant. In everyday life, this assumption works beautifully. As you glance at a clock and someone across the room glances at theirs, the times match, you speak, and they hear you almost immediately. Cause and effect feel neatly aligned. The world appears synchronized, as if everything is happening together in one shared moment. But this comforting sense of simultaneity depends on something very specific: proximity. When distances are small and speeds are slow, differences in time are too tiny to notice. Light travels so quickly across a room that it might as well be instant. Under these conditions, the idea of a universal now feels perfectly reasonable. It feels true. Yet the universe is not limited to rooms, cities, or even planets. As distances grow, the quiet delay carried by light becomes impossible to ignore. Light is fast, but not infinite. It always takes time to travel. This simple fact gently erodes the idea of a shared present. When you look at the moon, you see it as it was a little over a second ago. When you look at the sun, you see it as it was several minutes in the past. When you look at distant stars, you're looking back thousands, even millions of years. All of these views arrive together in what feels like your present moment, yet they belong to very different moments in the universe's history. Your now is already a collage of pasts. Someone standing far away gathers a different collage. Their present includes different slices of space-time. Neither perspective is wrong. Each is simply shaped by where the observer is and how information reaches them. This realization leads to a subtle but profound conclusion. There is no single, global present moment that everyone shares. Now is not stamped onto the universe like a universal timestamp. It is something that emerges locally, stitched together from the information available to each observer. Motion adds another layer to this picture. If two observers move relative to one another, they slice space-time differently. Events that appear simultaneous to one observer may not appear simultaneous to another. There is no deeper layer where these differences are resolved. Both perspectives are equally valid. This does not mean reality becomes subjective in a chaotic sense. The structure of space-time remains consistent. What changes is how that structure is divided into past, present, and future by different observers. A gentle metaphor can help here. Imagine reading a long scroll laid out on a table. One person starts reading from the left, another from the right. At any given moment, each person's finger points to a different part of the scroll. Neither is reading the wrong place. They are simply positioned differently along the same text. In this metaphor, the scroll is space-time. The finger is awareness. The place your finger rests feels like now. But it is not a universal marker. It is a local one. This idea can feel unsettling at first because it challenges something deeply emotional. The sense of a shared present helps us feel connected. It reassures us that we are all participating in the same unfolding moment. Letting go of that idea can feel like losing a common ground. But notice what does not disappear. Events still relate to one another. Causes still lead to effects. Conversations still unfold in order. The loss of a universal now does not dissolve meaning. It simply reveals that meaning does not require absolute simultaneity. In fact, the universe has been operating this way all along. It is only our intuition that needed updating. What we experience as now may be best understood as a psychological achievement. The brain integrates sights, sounds, and sensations, arriving at slightly different times and smooths them into a single, coherent moment. This integration is essential for survival. Without it, the world would feel fragmented and unstable. So the present moment is not something we discover, it is something we construct. This does not make it fake, it makes it functional. The illusion of a universal now is one of the brain's most elegant creations. It allows us to act decisively. It allows communication to feel immediate. It allows life to flow smoothly despite the underlying complexity of space-time. And because everyday life takes place at small scales, the illusion rarely fails us. Only when we stretch our imagination across vast distances and extreme motions does the stitching begin to show. This brings us to a quiet turning point. If the present moment is local and constructed, then our experience of time is more deeply tied to perception than we might have thought. The universe provides the structure, but the mind provides the narrative. We are not passive passengers carried along by a flowing river of time. We are active participants, assembling moments into something that feels continuous and alive. As this thought settles, it opens the door to a new direction. We have explored how physics loosens the idea of a universal now. The next gentle step is to look inward and ask how the brain itself builds the experience of time from fragments of sensation and memory. For now, it is enough to rest with this idea. The present moment is not a single, cosmic instant shared by all. It is a carefully woven experience shaped by light, motion, and the quiet work of the mind. And within that experience, life unfolds just as richly as ever. As the idea of a local, constructed present gently takes hold, another quiet realization comes into view. It is not dramatic, and it does not overturn what we have already explored. Instead, it deepens it. If now depends on how information reaches us, then the true mediator of time in our experience is not time itself, but light. Light is how the universe tells stories. Every sight you see, every star you notice, even every face you recognize arrives carried on light. Light is not merely illumination, it is information in motion, and because light always takes time to travel, every piece of information you receive is, by definition, a message from the past. This is not a poetic exaggeration. It is a simple consequence of how reality works. When you look at an object across the room, the light reflecting from it takes a tiny fraction of a second to reach your eyes. The delay is so small that your brain smooths it away. It feels instant, but it is not. You're seeing the object as it was a moment ago. When you look at the moon, the delay stretches to more than a second. When you look at the sun, the light you see left its surface several minutes earlier. And when you look at distant galaxies, the light may have been travelling for millions or even billions of years before reaching you. All of this arrives together in what feels like your present moment, so your experience of now is already a layered construction. It gathers together information from many different pasts and presents them as a single, coherent scene. The universe does not deliver reality all at once. It delivers it piece by piece, at the speed light allows. This has a subtle but profound implication. There is no way to experience the universe as it is right now in any absolute sense. There is only the universe as it was, filtered through distance and motion, arriving when it arrives. Even if you could somehow see across the entire cosmos, what you would observe would not be a snapshot of a single moment. It would be a vast mosaic of times, yet stitched together by the finite speed of light. This is not a limitation of our instruments, it is a fundamental feature of reality. Because information cannot travel faster than light, causality itself is shaped by this limit. Events can only influence other events once light, or something travelling no faster than light, has had time to connect them. This creates a structure in space-time, a pattern of what can affect what and when. To translate this softly, imagine a conversation shouted across a wide field. Words do not arrive instantly. There is a delay. The farther apart the speakers are, the longer the delay becomes. Each person responds not to what the other is saying now, but to what was said moments earlier. Yet the conversation still unfolds meaningfully. The universe works the same way, only on a much grander scale. Because of this, the idea of a universal present becomes even more difficult to sustain. There's no single moment that light is broadcasting everywhere at once. There is only a network of signals, each arriving according to distance and motion. This also means that the past is not gone in the way we often imagine. It continues to exist wherever its light is still travelling. In a very real sense, distant parts of the universe are still receiving information about events that, for us, are long over. This does not mean the past can be revisited or changed. It means that information about the past persists, woven into the structure of space-time itself. Seen this way, time becomes inseparable from communication. Without the transfer of information, time loses its operational meaning. Nothing can influence anything else. Sequences break down. The story stops being told. This perspective also helps clarify why time and light are so closely linked in modern physics. Light sets the ultimate speed at which cause and effect can propagate. It defines the boundaries of what can be known and when it can be known. Rather than thinking of time as a river carrying events forward, it may be gentler to think of time as the ordering imposed by information exchange. Events become meaningful to one another only when information has had time to travel between them. This does not make time less real, it makes it more relational. Your experience of the present moment is built from the information that has managed to reach you. Your memories are records of earlier information. Your expectations are projections based on patterns you have learned. Or at no point do you step outside this flow of information. Even your own body participates in this delay. Signals within your nervous system take time to travel. By the time your brain becomes aware of an action, that action has already begun. Conscious awareness lags slightly behind physical events, smoothing them into a story that feels continuous. So in a quiet but literal sense, you are always living a little bit in the past. This is not a flaw. It is the only way experience can work in a universe where information has a finite speed. The mind compensates beautifully, stitching together delays into a seamless present. Understanding this helps dissolve another common misunderstanding. The present moment is not a razor-thin slice separating a vanished past from an unreal future. It is a thick, layered construction, full of echoes and overlaps, and this layered present is not an obstacle to meaning, it is the foundation of it. Without delay, without memory, without anticipation, there would be no narrative, no learning, no continuity of self. As this idea settles, it gently nudges us inward. If time, as we experience it, is built from information arriving at different moments, then the brain must play an active role in assembling it. The universe provides the signals, but the mind weaves them into something that feels like a flowing now. That quiet realization invites us to turn our attention from the cosmos back to ourselves, to explore how the brain constructs time from memory, attention, and expectation, and why time can feel stretched, compressed, or even broken. For now, it is enough to rest with this image, light carrying stories across space, your information arriving patiently, never instant, always late, and a present moment that is not a point in time, but a living collage of the universe's past. As our attention turns inward, away from stars and clocks and toward the quiet workings of the mind, something important becomes clear. Whatever time may be in the universe, the time you experience is not simply received. It is built. The brain does not track time the way a clock does. It does not contain a tiny ticking mechanism counting seconds as they pass. Instead, the brain assembles time from pieces of experience. Sight, sound, touch, memory, expectation. All of these arrive separately, each on its own small delay, and the brain gently stitches them into a single flowing story. This stitching happens constantly without effort or awareness. You hear a sound and see a movement, and they feel simultaneous, even though the sound and the image reached you at slightly different moments. Light travels faster than sound. Nerve signals move at their own pace. Muscles respond before awareness catches up. Yet your experience feels unified, smooth, and whole. That smoothness is not given by the universe, it is created by the brain. To understand this, imagine a small editing room where pieces of a film arrive out of order. One clip shows a hand moving, another captures a voice speaking, another records a foot stepping forward. None of these pieces mean much on their own, but when the editor arranges them carefully, overlaps them slightly, and plays them back together, a coherent scene appears. Motion makes sense. Cause follows effect. A story emerges. Your brain is doing this kind of editing all the time. It collects sensory fragments arriving from different channels and aligns them into a shared timeline. This alignment is not perfect. It does not reflect exact physical simultaneity. Instead, it reflects what is useful. What helps you act, understand, and survive. This is why simultaneity as you experience it is a kind of illusion. Not a mistake, but a practical construction. The brain allows a small window in which events are treated as happening together, even if they are slightly offset in reality. Without this window, the world would feel jittery and unstable. Actions would lose their rhythm, conversations would fracture, so the brain trades precision for coherence. This trade-off becomes especially clear when you consider how awareness relates to action. By the time you consciously notice that you have moved your hand, the movement has already begun. The signal to move travels through the nervous system, muscles respond, and only then does awareness register what has happened. Conscious experience lags slightly behind physical reality. This lag is small, fractions of a second, but it is always there. Rather than causing confusion, the brain compensates. It gently backdates your awareness, aligning it with the action so that it feels immediate. You experience yourself as acting in the present, even though your awareness is arriving just after the fact. In this sense, you're always living slightly behind reality. Again, this is not a flaw, it is an elegant solution. In a universe where information takes time to travel, perfect immediacy is impossible. The brain's task is not to eliminate delay, but to manage it gracefully. Memory plays a crucial role here. Without memory, there could be no sense of time at all. Each moment would stand alone, disconnected from what came before. Memory links moments together, creating continuity. It gives you a past to refer to and a self that persists. At the same time, expectation reaches forward. Based on patterns learned from memory, the brain constantly predicts what is likely to happen next. These predictions help smooth experience even further. When events unfold as expected, time feels fluid. When they do not, time can feel strange, stretched, or abrupt. So time, as you live it, is not something you move through. It is something your brain actively constructs from memory and anticipation, layered on top of incoming sensory information. This construction is remarkably flexible. Under normal conditions, it works so well that we rarely notice it. But under unusual circumstances, its seams begin to show. Moments of intense focus, sudden danger, or deep absorption can alter how time feels, even though the physical world continues unchanged. These experiences hint at a deeper truth. Time perception is not fixed, it is adaptive. The brain adjusts its time-building process depending on context. When precision matters, it tightens the window. When survival demands rapid response, it reallocates attention. When nothing urgent is happening, it allows time to drift. All of this happens below conscious awareness. From this perspective, the sense of a flowing present moment begins to look less like a feature of the universe and more like a feature of the mind. The universe provides events, the brain orders them. Time, as experienced, emerges from that ordering. This does not mean that time is only in the head in a dismissive sense. The brain's construction is anchored to reality. It responds to real changes, real signals, real delays, but it also reshapes those inputs into something livable. The result is a present moment that feels stable, even though it is built from fragments arriving at different times, a sense of now that feels immediate, even though it is assembled slightly after the fact, a personal timeline that feels continuous, even though it is constantly being updated and revised. As this realization settles, it quietly reframes everything we've discussed so far. Physics describes how time behaves in the universe, but the time you inhabit, the time that feels like living, is shaped by the brain's ability to weave experience into a coherent narrative. That narrative does not run on a universal clock. It runs on meaning, memory, and expectation. And once we recognize that, another question naturally arises. If time is built from memory, what happens when memory changes? What happens when experiences become dense or sparse, emotional or dull? How does the brain's method of laying down memories stretch or compress the feeling of time itself? Those questions gently carry us forward. As the idea of the brain actively building time settles into place, another familiar mystery begins to make sense. If time is assembled from experience, then changes in experience should change the way time feels. And this is exactly what we observe. Time stretches, time compresses. Sometimes it crawls, sometimes it disappears altogether. The clock remains steady, but lived time bends easily. Think of a moment of fear, an unexpected fall, a sudden loud noise, a near accident. People often describe these moments in the same way. Everything seems to slow down, details sharpen, the world feels stretched, as if a single second has been pulled thin and wide. Later, when the moment is over, it feels as though it lasted much longer than it actually did. Now think of the opposite experience. A quiet afternoon absorbed in conversation. Hours pass unnoticed. When you finally look at the clock, you're surprised. Time seems to have vanished. In both cases, the physical passage of time is unchanged. The same number of seconds pass. The difference lies not in time itself, but in how the brain records the experience. This is where memory density becomes important. The brain does not store experience like a continuous video. It stores moments unevenly. Some periods are packed with detail, emotion, and novelty. Others are sparse and repetitive. When you later reflect on a period of time, your sense of its length depends largely on how much was recorded during it. Moments filled with strong emotion or new information generate dense memories. The brain lays down many distinct markers. When you look back, there is a lot to recall, and the interval feels long. Moments of routine generate fewer markers. When you look back, the memory feels thin, and the interval feels short. This explains a common illusion. Looking back on childhood, years can feel expansive. Yet everything was new. Days were filled with discovery. The memory landscape is rich. In adulthood, routines dominate. The memory landscape thins. Years feel as though they pass more quickly, even though they contain the same number of days. Time did not speed up. Memory changed. This also explains why boredom stretches the present. When you are bored, attention turns inward. You monitor time closely. Each moment stands out because there is little else to focus on. The brain marks the passage repeatedly, creating the feeling of slow movement. Fear does something different. It heightens attention outward. The brain records intensely. Even though the event may be brief, the density of memory makes it feel extended. In both cases, the experience of time is shaped not by clocks, but by how experience is encoded. and accidents provide a particularly clear illustration. During a sudden emergency, the brain prioritizes information gathering. It widens attention. Sounds, sights, and sensations are recorded in high detail. Later, when recalling the event, the sheer number of recorded elements gives the impression that the moment lasted much longer than it did. This can feel almost magical, as though time itself slowed down. But what actually happened is quieter and more elegant. The brain simply wrote a very detailed chapter. This understanding helps resolve a subtle confusion. We often talk about time as something that speeds up or slows down. In lived experience, this feels true. But what is really changing is not the flow of time, but the rate at which memory is formed. Time, as experienced, is a side effect of how memories are laid down, and this also means that the feeling of time is not fixed. It can change depending on attention, emotion, and context. Practices that alter attention, such as deep focus or mindfulness, often change how time feels. Moments become fuller. The sense of rushing softens. Experience thickens. Again, this does not mean time is unreal. It means that time, as lived, is flexible. The brain's primary concern is not measuring duration accurately. Its concern is making experience meaningful and navigable. Time perception serves that goal. When danger is present, stretching experience helps survival. When nothing demands attention, compressing experience conserves mental energy. From this perspective, the elasticity of time is not a bug, it is a feature. This also helps explain why the present moment feels so fragile. It is constantly being constructed from attention and memory. Shift attention, and time shifts with it. Change emotional tone, and the texture of time changes. Yet despite this flexibility, the brain maintains a remarkable sense of continuity. You experience yourself as the same person across changing moments. This continuity depends on memory linking one moment to the next. Time, memory, and identity are deeply intertwined. As we rest with this idea, another question quietly emerges. If time depends so heavily on memory, what happens when memory itself is disrupted? What happens when the brain can no longer reliably link before and after? The answer to that question reveals just how deeply time is woven into the sense of self, and why when time breaks, identity can begin to fracture as well. As the idea of memory shaping time settles, a deeper truth comes quietly into focus. Time is not just something you experience. It is something you rely on to remain yourself. The sense of a continuous identity, the feeling that you are the same person from one moment to the next, depends on the brain's ability to organize experience into a before and an after. When that organization falters, time begins to fracture. And when time fractures, the self often follows. Under ordinary conditions, the brain performs an extraordinary balancing act. It links memories together, aligns causes with effects, and creates a smooth narrative thread. You remember what happened earlier. You anticipate what may happen next. Between those two poles, a sense of me persists. You're not just a collection of moments. You're a story unfolding. But this story depends on temporal coherence. When the brain can no longer reliably place events in sequence, experience becomes disorienting. Actions lose context. Emotions feel detached from their causes. The sense of continuity weakens. People often describe this not as losing time, but as losing themselves. There are conditions in which this becomes painfully clear. Some individuals experience disruptions where memories no longer link smoothly. Moments feel isolated, as if they belong to different lives. Others report a loss of order, where events no longer line up into a clear sequence. The world still happens, but it no longer makes narrative sense. In these cases, time does not simply feel strange, it feels broken. This reveals something essential. Time is the quiet backbone of identity. It holds experience together so gently that we usually never notice it. Only when it fails do we realize how much we depend on it. Cause and effect play a central role here. When the brain can no longer reliably connect what happened to what follows, meaning begins to erode. Actions feel arbitrary, reactions feel unanchored, the world becomes harder to predict, and the self becomes harder to locate within it. This is not because reality has changed. It is because the brain's ability to organize reality into a temporal structure has been compromised. Even subtle disruptions can have noticeable effects. Moments may feel disconnected from one another. The present may feel unusually thin or unstable. People sometimes describe feeling out of time, as though they are observing their own life from a slight distance. These experiences can be deeply unsettling, but they are also illuminating. They show that time, as lived, is not optional. It is not a decorative layer added on top of experience. It is a structural necessity for a coherent sense of self. Memory once again plays a crucial role. When memory is fragmented or unreliable, the bridge between past and present weakens. Without that bridge, identity struggles to maintain continuity. The self becomes something that flickers rather than flows. Expectation matters too. The brain constantly predicts what will happen next. These predictions give experience direction. When that forward-looking function breaks down, the future loses its shape. Experience becomes trapped in a series of disconnected presents, each one arriving without clear relation to the last. This helps explain why time is so closely tied to mental health and well-being. A stable sense of time supports planning, learning, and emotional regulation. When time perception becomes unstable, these functions suffer. Importantly, this does not mean that time exists only in the brain. The universe continues to unfold according to physical laws. Clocks continue to tick. Events continue to occur. What changes is the brain's ability to align itself with that unfolding. This distinction matters. It prevents us from dismissing time disruptions as mere illusions. They are real experiences with real consequences. They reflect changes in how the brain interacts with reality, not a departure from reality itself. Seen this way, the self is not a fixed object but a process. It is maintained moment by moment through the successful organization of experience and time. When that organization works, identity feels stable and continuous. When it falters, identity becomes fragile. This realization casts earlier ideas in a new light. When we spoke of the present moment as a construction, we were not diminishing its importance. We were revealing its role. The present moment is where memory, perception, and expectation converge. It is the meeting point of who you were, who you are, and who you are becoming. Break that convergence and the sense of self begins to loosen. Yet there is something quietly hopeful here. The brain is adaptable. Time perception can recover. Memory can be relearned. Narrative can be rebuilt. The self, while fragile, is also resilient. More understanding time as a foundational structure of identity invites compassion. When someone struggles with disorientation or fragmentation, they are not failing to cope with reality. They're grappling with a disruption in one of the mind's most essential organizing principles. As this thought settles, it gently completes our inward journey. We have seen how the brain builds time, how memory stretches and compresses it, and how identity depends on its stability. Time is not just something we observe, it is something we live inside. And now, having explored time at the scale of the mind, we are ready to lift our gaze once more, to return to the universe itself and ask an even older question. Did time, like memory and identity, have a beginning? Or has it always been there, quietly holding everything together? Oh, that question carries us outward again, toward the earliest moments the universe can offer. As we lift our attention back out of the mind and into the vastness of the cosmos, the question waiting for us is an old one, and a quiet one. It does not demand an urgent answer, it simply asks to be considered gently. If time is so deeply woven into memory, identity and change, did it always exist? Or did time itself begin, much like everything else we know? To approach this question, it helps to imagine the universe not as it is now, filled with stars, planets and long histories, but as it once was, unimaginably early, when everything was closer, hotter and more tightly packed than we can easily picture. In those earliest moments, the universe was not dark and empty. It was bright beyond description, and matter and energy were mixed together in a dense, glowing fog. Light could not travel freely. Photons were constantly scattered, absorbed, and re-emitted, never moving far before colliding again. There were no clear paths, no long journeys, no distant signals arriving from afar. In such a universe, change still happened. Conditions evolved, expansion continued. But something familiar was missing. There was no clear way to measure those changes. Without freely travelling light, there was no reliable way for information to move from one place to another. And without the movement of information, the concept of time becomes strangely difficult to pin down. Earlier in our journey, we explored the idea that time is closely tied to change and information. Events become ordered because they can influence one another. Their causes lead to effects because signals can travel between them. But in this early universe, everything was so tightly coupled that distinct events were hard to separate. It is not that nothing happened. It is that before and after were not yet clearly distinguishable in the way we understand them now. This leads to a subtle but important idea. Time, as we experience and measure it, may not have been meaningful from the very beginning. It may have emerged gradually as the universe cooled, expanded, and allowed information to move freely across growing distances. As the universe expanded, particles combined into atoms. Light was finally able to travel long distances without constant interruption. The cosmos became transparent. Signals could propagate. Events in one region could influence events far away. Only then did something like a shared cosmic history begin to take shape. In this sense, time did not simply appear fully formed. It may have crystallized out of chaos, much like patterns forming in cooling liquid. Before that crystallization, change existed, but it lacked the structure we associate with time. This idea challenges the intuition that time must always be present. We tend to imagine time as the container in which the universe exists, but the early universe suggests a different possibility. The universe may have existed before time, at least before time as a meaningful ordering of events. This does not mean there was a moment before time in the usual sense. That phrase itself becomes slippery. Without time, the word before loses its usual meaning. What we are really pointing to is a regime where our familiar concepts no longer apply cleanly. In everyday life, time is what allows us to say that one thing happened earlier and another happened later. In the early universe, that distinction may not have been sharply defined. Everything was happening together in a dense, tightly connected state. Only as separation increased did ordering become possible. From this perspective, asking what happened before time may be like asking what is north of the North Pole. The question assumes a framework that no longer applies beyond a certain boundary. This does not make the question meaningless. It simply means that it points us toward the limits of language and intuition. What science can do here is offer gentle boundaries. It can tell us when our models work well, and when they begin to lose clarity. near the beginning of the universe, time becomes less like a smooth river and more like a foggy shoreline, where familiar landmarks fade. Some physicists suggest that time itself may have been born alongside space, emerging together as the universe expanded. Others propose that time existed in a different form, one not yet accessible to measurement. Still others suspect that time, as a fundamental concept, may dissolve entirely at the deepest levels. What these ideas share is humility. They acknowledge that time may not be a universal given. It may be a feature that appears under certain conditions, rather than a stage that always exists. This fits quietly with what we've already seen. Time depends on change. Change depends on interaction. Interaction depends on the ability to exchange information. When those conditions are absent or ill-defined, time loses its familiar shape. As we rest with this idea, it becomes clear that time may be younger than the universe itself. Or perhaps more accurately, time as we know it may be a latecomer, arriving only after the universe became structured enough to support it. This does not diminish time's importance. If anything, it makes time feel more precious. It is not an eternal backdrop, but a delicate ordering that emerged under specific conditions, allowing complexity, memory, and life to unfold. And here, at the edge of the universe's earliest moments, we encounter a new kind of uncertainty. Not just uncertainty about what happened, but uncertainty about whether our concepts apply at all. That uncertainty is not a failure. It is a sign that we're approaching the boundary of what can be meaningfully known. As this thought settles, it gently prepares us for the next step in our journey. If time may lose its clarity at the beginning of the universe, it may also lose its smoothness at the smallest scales. At the quantum level, where certainty gives way to probability, time itself may begin to shimmer and blur. That is where our attention will drift next. As we linger near the universe's earliest moments, another quiet shift begins to take shape. At vast cosmic scales, time feels smooth enough to trace with stories and histories. But when we drift down toward the smallest scales imaginable, that smoothness begins to soften. The steady flow we're used to starts to look less like a clear river and more like a gentle shimmer. This is the realm where certainty gives way to probability. At the smallest scales of reality, the universe does not behave like a collection of solid objects moving along clear paths. Instead, it behaves more like a restless sea of possibilities. Positions blur, energies fluctuate. Events do not always happen in neat, predictable sequences. The language of precision slowly dissolves into the language of likelihood. In this landscape, space itself is no longer perfectly still. It trembles subtly, never fully settling. These fluctuations are not violent. They are soft, constant, and unavoidable. And if space behaves this way, it invites a natural question. Could time behave similarly? Instead of ticking forward in perfectly even steps, time at the smaller scales may wobble gently, not enough to notice in daily life, not enough to disrupt the steady rhythm of clocks, but enough to suggest that smooth time is an approximation rather than a fundamental truth. To imagine this, picture the surface of a calm lake. From a distance, it looks flat and glassy, but as you move closer, small ripples appear. Zoom in further, and the surface is alive with tiny motions. The lake has not changed, only your perspective has. Time may be similar. At human scales, it flows smoothly. At cosmic scales, it tells long stories. But at the deepest levels, it may be granular, jittery, or softly indeterminate. This does not mean that time randomly jumps or breaks apart. It means that the idea of a perfectly smooth timeline may be something that emerges only when many small uncertainties average out. Some physicists have proposed that there is a smallest meaningful interval of time, beyond which the concept of earlier and later loses clarity. Below that scale, asking what happens before or after may no longer make sense in the way we expect. Time, like distance, may come in indivisible grains. Rather than naming numbers or invoking unfamiliar units, it is gentler to think of this as a limit to resolution. Just as there is a smallest detail your eyes can see before everything blurs together, there may be a smallest interval your universe can meaningfully distinguish. Within this view, time is not infinitely precise. It is sufficiently precise for the stories that matter, but not infinitely sharp at its edges. This idea also fits with the earlier thought that time depends on change and information. If events at the smallest scales cannot be cleanly ordered, then time itself becomes less defined there. Order emerges only when interactions are large enough and stable enough to support it. Researchers have proposed subtle experiments to explore this possibility. These experiments do not attempt to stop time or observe it directly. Instead, they look for tiny irregularities in how events line up, searching for signs that time itself introduces a faint blur. So far, time has behaved remarkably well. It appears smooth and reliable even under close inspection. But the search itself is revealing. It tells us that time is not taken for granted. It is tested, questioned, and gently probed. What emerges from these efforts is not a picture of chaos, but of limits. Limits on how finely time can be defined. There are limits on how much order can be extracted from the smaller scales. These limits echo a theme we have encountered before. The universe is not obligated to be fully knowable. It allows structure and pattern to emerge, but it also guards certain depths with uncertainty. Importantly, this uncertainty does not undermine the reality of time at everyday scales. Just as the ripples on a lake do not prevent boats from crossing it, small-scale fuzziness does not prevent history, memory, or causality from functioning. The world remains stable where stability matters. This layered structure, smooth at large scales, uncertain at small ones, appears again and again in nature. Temperature emerges from countless tiny motions. Solidity emerges from interactions among particles. Time, too, may be an emergent phenomenon, and gaining clarity only when conditions allow. Seen this way, time is neither fully fundamental nor merely illusory. It is something in between, a structure that arises from deeper processes, robust enough to support galaxies and minds, yet delicate enough to lose definition at the edges. This perspective encourages a gentle humility. When we ask what time truly is, we may be asking a question that has no single, simple answer. Time may wear different faces at different scales, revealing smooth order here and soft ambiguity there. As this thought settles, it becomes clear that the mystery of time is not a single puzzle to be solved, but a landscape to be explored. Each layer offers its own insights, its own limitations. And this prepares us for a familiar curiosity, one that inevitably arises when time begins to feel flexible and uncertain. If time can bend, slow, and even blur, can it be navigated? Can it be travelled? The calm answer to that question turns out to be both simpler and more grounded than imagination often suggests. After exploring the softness of time at its smallest scales, it may feel natural to ask a question that has long captured human imagination. If time can bend, stretch, and blur, can it also be travelled? Science fiction often treats this as a dramatic puzzle filled with machines, paradoxes, and flashing lights. The real answer, however, is much quieter and far more grounded in everyday reality. In one direction at least, time travel is not only possible, it is already happening. Travelling forward through time is not a fantasy. It is a measured physical process that occurs whenever motion and gravity come into play. The reason it feels ordinary is that the effect is usually small, so small that it hides comfortably within daily life. To understand this, return to the idea that time flows differently depending on how you move through space-time. Earlier, we saw how clocks behave when they are placed at different heights or carried along fast-moving paths. Those experiments were not demonstrations of strange anomalies. They were demonstrations of time travel in its most practical form. Imagine two identical twins. One stays on Earth, the other boards a spacecraft and travels at extremely high speed before returning. When they reunite, the travelling twin is younger, not by years in ordinary circumstances, but by a measurable amount. Fewer internal changes occurred along their path. Their personal timeline advanced more slowly. This is not a trick of perception. It is not a biological illusion. It is a physical difference in how much time actually passed for each twin. To translate this gently, imagine two notebooks. In one, pages are filled steadily. In the other, pages are filled more slowly. When you compare them later, one contains fewer entries. That notebook has experienced less change. That is what it means to age less. Astronauts experience this effect, though on a very small scale. Those who spend long periods orbiting Earth age slightly less than people on the ground. The difference is tiny, but real. Their clocks, their bodies, and their biological processes tick just a bit more slowly because of their motion and position. Even subatomic particles demonstrate this behaviour. E-particles moving near the universe's ultimate speed limit survive longer than expected when observed from a stationary frame. Their internal processes unfold more slowly. They travel farther than they otherwise could, simply because time passes differently for them. All of this reinforces a single calm conclusion. Forward time travel does not require exotic machines. It requires motion and gravity. The faster you move, or the deeper you travel into a gravitational field, the more you step ahead of others along the timeline. Why then does this not feel like time travel? The answer lies in scale. Human speeds are slow compared to the universe's limits. Earth's gravity is gentle compared to the gravity near massive cosmic objects. Under these conditions, time behaves almost like the steady background we're used to. The differences accumulate slowly, quietly, over long periods. But almost is doing important work here. Given enough speed or enough gravity, the effect becomes significant. In principle, someone could travel far into the future of the universe by moving along an extreme path through space-time. When they return, they would find that far more time has passed for everyone else. This kind of journey does not violate causality. It does not allow messages to be sent backward. It does not create paradoxes. It simply reflects the flexibility of time itself. In this sense, time travel to the future is not a loophole in physics. It is a natural consequence of how space-time works. What often confuses people is that we tend to imagine time travel as stepping outside the universe and re-entering at a different moment. But real time travel is more like choosing a different route through the same landscape. Some paths are longer in time than others, some are shorter. Your own life is already such a path. Every moment you experience is shaped by your motion, your surroundings, and your position in the universe. You're already travelling through time at a rate defined by your journey. This realization gently reframes the question. Instead of asking whether time travel is possible, we begin to ask how different paths through space-time affect the passage of time. The answer is reassuringly consistent. There are no shortcuts to the past hidden in this picture. There are no sudden jumps or reversals. There is only variation in how much time unfolds along different paths. This makes forward time travel feel less like science fiction and more like an extension of ordinary life. It is not dramatic. It is not dangerous. It is simply physics. As this idea settles, it becomes clear why discussions of time travel often feel misleading. They focus on extremes while ignoring the quiet reality that time travel already occurs in small measured ways. Understanding this also prepares us for the next question, one that naturally follows. If travelling forward through time is so straightforward, why does travelling backward remain so elusive? What makes the past so resistant to revisiting? The answer reveals another layer of time structure, one that places firm boundaries around what the universe allows. After seeing how quietly natural forward time travel can be, it is tempting to ask the question that has lingered in human imagination for centuries. If moving into the future is allowed by the structure of space-time, why does moving into the past feel so forbidden? What makes yesterday so resistant to revisiting? The answer is not dramatic. It is not guarded by explosions or cosmic alarms. It is built gently into the way the universe organizes cause and effect. To begin, it helps to notice a simple asymmetry in everyday life. You can remember the past, but you cannot remember the future. You can break a glass, but you cannot watch its shards leap back into your hand. These observations feel obvious, almost too ordinary to question, yet they point to something deep. Time, as we experience it, has a direction. This direction is often called the arrow of time. Rather than thinking of it as an arrow shot forward, it may be gentler to think of it as a slope. Events tend to move downhill from ordered states to disordered ones. Spilled milk does not unspill. Heat spreads rather than concentrating itself spontaneously. Causes reliably come before effects. This tendency is not enforced by a cosmic rulebook. It emerges from the statistics of large systems. When many small interactions occur together, certain directions become overwhelmingly likely. Going backward is not strictly impossible in theory. It is simply so unlikely that it never happens in practice. This is one reason backward time travel remains elusive. To move into the past would require not just bending space-time, but reversing an immense number of relationships simultaneously. Every interaction, every exchange of energy, and every transfer of information would need to unwind in perfect coordination. At small scales, such reversals are not forbidden. A few particles can retrace their steps under controlled conditions, but scaling this up to people, planets, or histories quickly becomes unimaginably complex. The universe does not offer a reset button. Some mathematical descriptions of space-time do include paths that loop back on themselves. These loops appear in solutions involving extreme conditions, such as rotating universes or highly curved regions of space-time. On paper, these paths suggest the possibility of returning to an earlier point along one's own timeline. However, these descriptions are not instructions. They are mathematical possibilities, not practical blueprints. To translate this softly, imagine drawing a map of all possible routes through a mountain range. Some lines on the map may cross in strange ways, some may even circle back, but drawing a line does not guarantee that the terrain allows safe passage. Steep cliffs, unstable ground, or missing bridges may make certain paths unreachable in reality. The universe appears to work the same way. Equations can describe exotic geometries, but physical constraints decide what can actually exist. Black holes often enter these discussions surrounded by mystery and speculation. Popular culture sometimes portrays them as gateways to other times or places. In reality, black holes are not time machines. They are regions where gravity becomes overwhelming, trapping matter and light beyond a boundary. Crossing that boundary does not send you into the past. It removes you from the future as we understand it. Inside such regions, our current descriptions of physics lose clarity. But nothing suggests a reliable path back to earlier moments. Whatever happens there, it does not resemble a rewind button for the universe. Wormholes offer another frequently mentioned idea. These are hypothetical shortcuts connecting distant regions of space-time. In some speculative scenarios, they could connect different times as well as different places. But even here, enormous obstacles arise. Wormholes, if they exist at all, would be extraordinarily fragile. The slightest disturbance could cause them to collapse. Keeping one open long enough to pass anything through would require conditions far beyond anything we know how to create or stabilize. More importantly, even if such a structure could exist, it would not grant free movement into the past. It would still obey the broader rules of causality. Paradoxes do not simply appear because we imagine them. The universe has a way of protecting its consistency. This protection does not feel forceful. It feels quiet, like a landscape that allows walking in many directions, but not all. From this perspective, backward time travel is not forbidden by a single law. It is discouraged by an entire web of constraints. Energy conditions, stability requirements, and the arrow of causality all lean in the same direction. Forward motion through time is easy, because it aligns with how the universe naturally unfolds. Backward motion is hard because it would require undoing that unfolding step by step across countless interactions. This helps dissolve the sense that backward time travel is being withheld unfairly. It is not banned. It is simply incompatible with the way complex systems behave. There is also a quieter, more human reason why the past resists revisiting. The past is not just a location in space-time. It is a structure of memories, causes, and consequences. To return to it would mean disentangling meaning itself. Every decision, every outcome, every learned pattern would need to be unwritten. Time, as we have seen, is deeply tied to information. Once information has spread, once events have influenced other events, that influence cannot be erased without erasing the entire network. So the universe moves forward not out of stubbornness, but out of coherence. As this understanding settles, backward time travel begins to feel less like a missed opportunity and more like a boundary that preserves stability. Without such boundaries, narratives would collapse, identity would unravel, cause and effect would lose their anchor. In this light, the one-way nature of time is not a limitation imposed on us. It is a condition that makes experience possible, and this realization gently guides us toward a broader perspective. If time travel is constrained not just by physics, but by the needs of coherence and meaning, then time itself may be something shaped as much by life as by laws. That thought invites us to step back once more, beyond equations and paradoxes, and consider how different minds and cultures have learned to live with time in their own ways. As we step away from equations, paradoxes, and cosmic boundaries, something quieter waits for us. If time bends in physics, stretches in memory, and resists reversal in the universe, then how have humans learned to live inside it? The answer turns out to be deeply human. Time, as we use it, may be less a universal constant and more a tool, a cognitive technology shaped by survival, culture, and meaning. It is easy to assume that everyone experiences time the same way. After all, clocks agree, calendars align, and days pass with familiar regularity. But when we look across human history and across cultures, a more flexible picture emerges. Not all societies have organised life around abstract units, like hours, minutes, or years. Many have lived quite comfortably without them. In some cultures, time is not measured but described. Events are placed in relation to other events rather than on a numbered timeline. Instead of saying something happened 3 days ago, one might say it happened after the last heavy rain, or before the harvest. Time, in these contexts, is woven directly into lived experience. This way of organising time is not primitive or vague. It is precise in a different way. It ties memory to meaningful change rather than to abstract counting. Seasons matter because they affect food. Daylight matters because it shapes activity. The passing of time is felt through transformation, not through numbers. Seen this way, time becomes a practical invention, a way of coordinating action, memory, and expectation. As societies grew more complex, more precise timekeeping became useful. Trade, travel, and communication demanded shared schedules. Clocks and calendars emerged as social tools long before they were treated as windows into the nature of reality. This does not mean time is imaginary. It means that the way we package time is adaptive. The human brain excels at building tools that compress complexity. Language is one such tool, numbers are another. Timekeeping combines both. It allows us to take the continuous flow of change and divide it into manageable pieces. Hours, days, and years become handles we can grasp. Once these handles exist, they begin to shape how we think. We plan futures. We recall pasts. We measure progress. Time becomes something we feel we can spend, save, or lose. But beneath this structure, the older, more flexible sense of time remains. We still feel time slow during moments of intensity and speed up during routine. We still mark life by milestones rather than by minutes. Births, losses, beginnings, and endings matter more than dates on a page. This suggests that abstract timekeeping is layered on top of a more fundamental, experience-based sense of time. The tool does not replace the intuition, it refines it. Evolution likely played a role here. Organisms that could anticipate change had an advantage. Remembering what came before helped avoid danger. Predicting what came next improved survival. Time perception became intertwined with learning and adaptation. From this perspective, time is not just something we perceive, it is something we use. This idea becomes even more intriguing when we consider the possibility of other minds. Different animals perceive time differently. Some respond to rapid changes that humans barely notice. Now, others operate on much slower rhythms. Their internal clocks, shaped by their needs, do not match ours. If intelligence arises elsewhere in the universe, there is no guarantee that it would organize experience around time in the same way we do. Another mind might prioritize patterns, cycles, or relationships without dividing existence into past, present, and future as sharply as we do. Time, then, may not be a universal language. It may be a local dialect, shaped by the constraints and goals of a particular kind of mind. This realization softens the temptation to treat our experience of time as the default. It invites humility. The universe may support many ways of organizing experience, of telling stories, of tracking change. Even within human life, we move fluidly between different time frameworks. We switch between clock time and emotional time, biological time, and narrative time without effort. Each serves a purpose. None is complete on its own. Clock time helps us coordinate. Emotional time helps us assign meaning. Biological time governs rhythms of sleep and wakefulness. Narrative time helps us understand who we are. All of these coexist. None cancels the others. When we say time is a cognitive technology, we are not reducing it to a trick. We are recognizing its role as a tool that bridges mind and world. It allows us to synchronize with others, to learn from the past, and to imagine futures that have not yet arrived. And like all tools, time shapes the user. Living with precise timekeeping changes how we experience urgency, patience, and rest. It can create pressure or provide structure depending on how it is used. As this thought settles, it gently prepares us for the final step of our journey. If time is shaped by physics, constructed by the brain, refined by culture, and limited by information, then complete knowledge of time may be impossible. Not because we have failed to understand it, but because time itself may be something that resists total capture. As our journey gently slows, we arrive not at a final answer, but at a quiet boundary. After exploring time in physics, in the brain, in culture, and in the vast architecture of the universe, one truth becomes increasingly clear. Time is not something that can be fully held, measured, or mastered. It is something we move within, something that shapes us even as we try to understand it. There are limits written into the structure of reality itself. In physics, we encounter limits again and again. Yeah, limits to speed, limits to precision, limits to how much information can be known about a system at once. These are not temporary gaps waiting to be filled. They appear to be fundamental features of the universe. Time, it seems, is wrapped tightly around these boundaries. Earlier we saw how the finite speed of information prevents any observer from knowing what is happening everywhere at once. We saw how uncertainty blurs the smallest scales, how the beginning of the universe resists clean description, and how the past refuses to be undone. Together, these ideas suggest that time is not a puzzle with a final solution waiting at the end. Instead, time may be something like a horizon. You can approach it, you can map it, you can understand its shape locally, but you can never stand beyond it and see everything at once. This is not a failure of intelligence, it is a feature of existence. Even in everyday life, this limit shows itself quietly. You never experience the present in isolation. It always arrives carrying memory and expectation. You cannot fully know what the next moment will bring, no matter how carefully you plan. The future remains open, not because it is empty, but because it is not yet accessible from where you stand. Prediction, no matter how refined, always carries uncertainty. Weather forecasts, life plans, scientific models, all of them work within margins. They are tools for navigating possibility, not for eliminating surprise. Time protects surprise. This protection may be essential. A universe where everything could be known in advance would leave no room for learning, choice, or meaning. The flow of time, with all its limits, creates space for becoming. This perspective invites a shift in how we relate to time. Instead of seeing it as something to conquer or escape, we can see it as a condition that makes experience possible. Time allows stories to unfold. It allows growth. It allows rest after effort and change after stillness. From this point of view, the mystery of time is not something to be solved away. It is something to be lived with. We can know many things about time. We can measure how it bends under gravity. We can trace how the brain assembles it. We can recognize how culture shapes it. But we may never reach a single unified definition that captures all of it at once. And that may be exactly as it should be. At the human scale, time matters because it is finite for us. Our lives are bounded. Moments pass and do not return. This finiteness gives weight to experience. It is why choices matter. It is why memories feel precious. It is why attention has value. If time were infinite in our lives, urgency would dissolve, meaning would thin. The very things that feel heavy and beautiful about being alive would lose their texture. So perhaps the deepest truth about time is not found in equations or theories, but in how it shapes care. We care because time passes. We love because moments are limited. We rest because we cannot go on forever. In this sense, time is not an enemy to outrun. It is a companion that gives form to experience. As we come to the end of this exploration, it is worth noticing where we began, with a simple question about whether time is fundamental or constructed. Along the way, we found that it is both, and neither, depending on where you look. Time is woven into the universe but also assembled by the mind. It is measured by clocks but felt through memory. It is constrained by physics but shaped by culture. Time is not one thing. It is a relationship between change, information, and awareness. And like all relationships, it cannot be fully reduced to a single description. So we end not with certainty, but with a quieter understanding that not knowing everything about time does not diminish our place within it. It deepens it. It reminds us that we are participants, not observers standing outside the flow. And now, as this journey gently comes to rest, there is nothing left to solve, no final concept to hold on to, just the simple fact of being here, in this moment that feels like now, even if we know it is a careful construction. Whether your eyes are still open or already drifting closed, thank you for spending this time exploring one of the universe's most subtle mysteries. If you'd like to join me again for more quiet wanderings through science and thought, you're always welcome. You can subscribe or share this with someone who might enjoy a peaceful pause. Time has a way of slipping through our fingers, but here, in this quiet space, there is nothing you need to chase. Just rest. Let the moments pass as they will. Sleep peacefully, wherever and whenever you may be.